Today, software defines vehicles. New cars are shipped with literally millions of lines of code, controlling everything from comfort to performance and, most importantly, safety. But how can we ensure that our software is released safely without any costly errors? Well, we have to find bugs early through testing. With our solutions for virtual vehicle development, you get a seamless continuity in your testing strategy, from testing on mill to sill to hill. When developing your ECU, you start with the core functionality, which in our case would simply be the AAB deciding when to brake in an emergency. This is known as classic model-in-the-loop testing. So the algorithm responsible for that you would usually build and verify in MATLAB in an open-loop setup. With CarMaker, however, we are able to bring that exact model into our simulation, which moves us to a closed-loop setup. So that algorithm, that model, already drives and reacts to a realistic environment. As you can see, the entire proving ground here is replicated virtually, including the vehicle and the pedestrian. So our AAB model is now fully verified, but this makes up at most the application layer of our ECU. An actual ECU consists of way more code, obviously, such as the runtime environment or basic software. And as our software stack grows in complexity, our test objectives also change. We now want to focus on things like integration, communication, timings, or diagnostics. And many of these tests can still be done without the requirement of any physical hardware. And this brings us to software-in-the-loop testing. Now, to validate a virtual ECU, or just VCU for short, we've partnered with Synopsys, enabling us to run a powerful code simulation between CarMaker and Synopsys Silver. The full software stack of our virtual ECU is being run in Silver, and through CarMaker, we can execute not only signal-based tests, but also do message-based testing. And all of this while still being able to use our NCAP scenarios from earlier. And this is precisely what makes SIL so powerful. Since we are basically free of any real-time constraints, since this setup does not require any hardware, you are able to push all of these tests directly to the cloud, massively increasing the speed in your testing strategy. At some point in your development process, you simply won't get around testing on hardware anymore. But the typical system hill that you would usually find with full ECU networks, they have big limitations. They are expensive, they take enormous time to set up, so they are hardly scalable. But scaling and parallelization is something that becomes really important at this stage. Why? Because on SIL, we were able to just accelerate our simulations to speed our testing strategy up. But on HIL, we have to do real time. Now our so-called Rapid HIL approach aims to fix exactly this issue. The idea is that you keep only your device under test as actual physical hardware, so this would be the AAB in our case, and connect it via a PCAN USB adapter to your Windows machine or even to our real-time system XPack. This makes it super easy to scale it up and distribute all of your different tests as necessary, and afterwards evaluate all the results with ease. And as you can see, we continue to use the same NCAP scenarios that we've already been seeing on mill and sill, ensuring continuity across all stages. With our solutions, we can ensure that your software works as intended and you're spared of costly product recalls. Today we've been looking at a typical ADAS function like the AAB, but really your application could be virtually anything. With our solutions for virtual vehicle development, we can ensure that you deliver better software faster.